Welcome back to this video. In the last lesson, we introduced the binary search tree. We saw how to draw a binary search tree, being it with integer values or string values, and an exercise was equally given. I hope you watching this video, you passed through the previous one and you were able to answer all the questions. For those of you who could not, I am waiting you to join our channel, our WhatsApp group and our WhatsApp channel, sorry, and our Telegram channel, where the solutions are going to be posted during the weekend. Now, today we are going to look at inserting nodes in a binary search tree. Inserting a node at the correct position means that the new node should not violate the properties of the binary search tree. Can you remind us about the different properties of a binary search tree we saw last lesson? Good. We saw that there were four different properties. The three main properties are: the left subtree of a node must contain values less than the node itself. The right subtree must contain nodes with values greater than the node's value itself. The third one is that each subtree follows the properties of a BST, and the last one is there is no repetition of nodes. Those are the four properties of binary search tree we saw. So now we are saying that inserting a node in a binary search tree, personally, I see it like, not even personally, generally, it is just like you are inserting the last node in a binary search tree, because you need to compare with the root. You move to the left subchild or the right subchild and do the different comparison till you will find its place. So now, example, consider the tree below. If we want to insert 12 and 55, the tree will change as follows. So if I want to insert 12, first of all, when you come here, 12 is below 45. So we come here, 12 is below 39. So it means that 12 should be inserted as what? The left child of 39. And this is what we have, as you can see. If I want to insert now 55, you come here, 55 is above. When you come here, 55 is below. When you come here, 55 is above. So 55 should be inserted as the right subchild of 54. And that is what we have. As easy as that. Now, deleting nodes in a binary search tree. Deleting a node from a binary search tree should be made in such a way that the properties of the BST are not violated and nodes are not lost in the process. That is, if I'm deleting one node, the resulting binary tree should be the original minus one node only. We have three different cases. Case 1, deleting a node that has no children. In this case, we simply remove the node from the tree. This is the simplest case of deletion. For example, if I have this, look at 78. 78 has no children. So if I want to delete this, I will simply remove. As you can see, I just erase it from memory. That's what we have. Case 2, deleting a node having one child. With this case, the node's child simply replaces the node. Now, if the node is the left child of its parent, the node child becomes the left child of the node's parent. So what are we saying here? Look at this case. If I want to delete 54, you see that 54 was the left child of 56. So 55, we simply come and replace. It's just like our tradition in Cameroon. When a man dies, provided he had only one son, that son is the one inheriting all his properties legally. So let us proceed. Now, if I want to delete 54, I will simply erase this 54 and 55 will come and replace it. So this is what we have. And is that the properties are still maintained because all these values are above 45. This is below 45. This is below 56. And this is above 56. So this is what happens when you are deleting a node having one child. Just there, the child simply replaces a node. Now, case 3, deleting a node with two children. This case can be handled in two different ways, either by replacing the node to be deleted by the in-order predecessor, that is the largest value in the left subtree, or in-order successor, the smallest value in the right subtree. That is it. In some tradition in Cameroon, they will always tell you it's the last born that is the successor, or it is the first born that is the successor. In some, the father decide whatever he wants. But when it comes to trees, when a node dies, or let me say we are deleting here, deleting means that he died. we can replace him either by the in order predecessor or the in order successor. Let us look at an example. Delete the node 56 from the BST and draw the resulting BST. So this means that deleting a node having two children can result to two different binary search tree. And in some questions, they precise with which node you have to replace it, either by the in order successor or the in order predecessor. So what do we mean here? We are simply saying that, first of all, remember that, let me give you, it is true which I see, but let me just tell you at once. In order traversal on a binary search tree is the traversal order that gives the node in ascending order. That is why when they say in order predecessor, it simply means the value directly behind the node. That's why we say the largest value in the left subtree. And when we say in order successor, we are talking about that value that is directly next to the root, to the node, sorry, when we are giving them in ascending order. That's why we say in order successor or in order predecessor. Now, at this level, we are deleting 56. We divide, as you can see, this is the in order predecessor, this particular region. So when you divide this 15 into 2, you see that to the left you have 54 and 55, and to the right, which are the in order, we have 78 and 80. Please take note, I am not saying that 54 is my in order predecessor or that 78 is my in order successor. No, I am just giving you the different ways after division, that the one on the left is where we have our in order predecessor, and to the right it is where we have our in order successor. Please, now, to the left, what is the maximum value to the left? It is 55. So this is what I'm going to have, as you can see. So as I'm deleting 56, it is 55 that will come and replace him, as you are seeing. So 55 come and replace him. That is, you come to the left, you take the maximum child, because on the left of 56, I have 54 and 55. Between them, who is the maximum? It is 55. That's why 55 is the one replacing him. So when I use the in order predecessor, this is my resulting binary search tree. But if I come on this side to the right, I must take the lowest value, which is 78. So in this case, 78 is the one that replaces the node 56, as you can see. So deleting 56 result in these two different binary search tree. So case 3 is the only case whereby we result in two different binary search tree, whereas case 1 and case 2, same thing as inserting a node, result in only one unique binary search tree. So that is what we have when it comes to inserting and deleting a node in a binary search tree. In order to be sure that you understood this important concept, I would like you to go through this particular question, the Littoral Regional Mock 2022, question 3 sub 2. Consider the following binary search tree. This is the binary search tree you have. So this is our root, as you can see. Now they say give the pre-order and the post-order traversal of the tree for 2 marks. Draw the same binary search tree after the insertion of the keys 6, 45, 32, 98, 55, and 69. So they are indirectly asking you to add these keys here. It's not that you are drawing after adding one. No, the binary tree you must have at B should be one binary tree containing this node already and this node already inserted. The C part says draw the binary search tree resulting from the deletion of key 9 and 45 from the binary search tree resulting from question B. So from the binary tree you obtain in B, you have to delete 9 and 45 and draw the resulting binary search tree. This question came for 7 marks. So dear students, I am waiting for your solutions. And remember, in our WhatsApp channel, my private number is given in the description of the channel. I am waiting for your answer. And in case you have any doubt about the chapter that was already done, you can PV me and you will get better explanation. Thank you and see you next class.